This is team number
1045.
and we're participating in SCUDEM 2025. We chose problem B in AI Ouroboros. I'm Anjali Tomerlin.
I'm Grigoruk.
And I'm Keon Moghaddam. So as people create more AI-generated content, AI models will be trained on data either created by itself or other AI models. We want to see how training AI models on this AI-generated data will affect the model's output quality over time. When we say data pool, we mean text content published on the internet at a given time. This includes either AI-generated content or human-made content. When we say AAR, that stands for AI attribution rate. It's the proportion of text on a platform that we suspect to be AI generated. So for example, if we suspect 30% of a platform's content to be AI generated, the AAR would be 0.3. Medium.com is a social media platform that hosts text content. When we say processed, it is the act of data being lost or reinterpreted when manipulated by an AI model. So when an AI model is given information, it will output data with its own abstractions that is less accurate to reality. Some limitations of our model are, for one, our model only considers the behavior of AI in a closed internet environment, in this case Medium, when in reality AI models are trained on data from all over the internet. Secondly, we also consider AI-generated content to be content generated by ChatGPT, Google Gemini, and Microsoft Copilot, when in reality a lot more AIs contribute. And we also suppose that a constant number of new data is being added to the data pool each month, when in reality a changing number of content is being added to the data pool each month. So each month there isn't a constant amount of posts to Medium. First assumption is motivated by the logic that an AI model being trained on its own data is reaffirming its own biases and errors. Our second assumption is based on the idea that prior to December 2022, there was no widely available AI model such as ChatGPT. Our third assumption is a simple estimate based on our research and public information. And we made our last assumption for the sake of generalizing our findings to any AI model. And this is a diagram that shows the structure of our model, where AI models are trained at the end of each month on data generated during the middle of the month and all data previous posted on Medium. So the input of our model T represents the number of months since the end of November 2022. For example, T equals 1 represents the end of December 2022. The output of our model is the average number of times that a piece of data in the data pool has been processed by ChatGPT, Gemini, and Copilot. For example, mu sub CG of 1 equaling 0.03 means on average every piece of data in the data pool at the end of December 2022 has been processed by ChatGPT 0.03 times.
We model every single piece of data in the data pool as having its own vector of CG, GI, and CP values. These represent how many times that piece of data, and on average, the data in which its source model was trained upon has been processed. The reason that we average out the data which the source model was trained upon is because we suspect that if the source model was trained upon highly processed data, it would affect its output as well. And so for every single new piece of data added to the pool at a time t, there are 4 sources it can come from: humans, ChatGPT, Gemini, or Copilot. If it was human-made, then we expect these vectors of process values to all be 0, since they're not processed by an AI at all. And if it was AI generated, then we average out the processed values, each of the 3 processed values at the time t minus 1, and then increment the corresponding component of the AI model by 1 for whatever it was created by. So for example, if a piece of data was created by ChatGPT, we would average out all 3 of the processed values and then plus 1 to the mu sub CG of t minus 1 value, because it was processed by ChatGPT a singular time by virtue of its creation.
This is a visualization of the model process we just spoke of. At time t equals 0, we have 3 data points, which are all human-made and are in the initial data pool. And then at time t equals 1, we have 4 new data points, 2 from ChatGPT, 1 from Gemini, and 1 human-made. You can see the human-made has 0 for its components because it was not processed at all. And then the 2 for ChatGPT, they have 1 because we took the average at time t equals 0 of the ChatGPT component and the Gemini components. And then we added 1 to signify that ChatGPT processed that data. And we did the exact same thing for Gemini. And then at time t equals 2, we had the same process once more, where we took the averages of time t equals 1 and we added 4 new data points, along with everything from the old data pool as well.
So in the previous visualization of the model, we were adding a constant new number of data pieces from each source, but in reality, we don't expect this. And so these functions, these 4 different functions, n sub CG, n sub GI, n sub CP, and n sub HM, are representing how many new pieces of data are added to the pool at a time t, and we calculate this using the number of new Medium posts made each month, the proportion that we expect comes from each model, and a beta regression on AAR, which we will explain soon. And n sub AI just represents the total number of posts made by each different AI model combined. So the beta regression we spoke of, we ended up constructing it because published data actually only reports AAR values until the end of October 2024, but our model extends to T beyond this, so we need to extrapolate these values. And we chose a beta regression because it cleanly bounds the AAR between 0 and 1 since it's a proportion. And so we can see in the graph here, the dots in red are the original published AAR values, and the dots in blue are the ones that we are using, which is the beta regression fit to them. So this is a bar chart visualizing the percent composition of new monthly generated data on Medium.com, and you can see that as time goes on, the percent composition of human generated content is going to decrease as asymptotically AAR approaches 1 according to the beta regression. This is just a summary of our final model. Step 1 is representing the initial data pool, which we assume to be 12 million human-made posts. Step 2 is the new posts that are made on Medium.com in the middle of each month, and they are added to the pool of data, and the number of new posts that are added to the pool are given by the N at T values that we previously calculated, those different functions. Step 3 is the AI models that are being trained based on this new data, and step 4 is the averages of the processed values being recorded, and then steps 2 through 4 are repeated for every single month recursively.
The output of a model is a vector of the average processed values across a data pool for each AI model at a time t, and we can attain this vector by dividing the sum of all the processed values in the data pool and dividing it by the number of data points in the data pool. Right, so we define this recursive function where s of 0 is a 0 vector, and then s of t is these three values summed together. The red value is the vector of the amount of data created by each model at a time t. And then the blue vector is the averages for the number of times each piece of data in the pool has been processed by each model at time t minus 1. And we multiply it by the number of content made by AI at a time t. And then we just add the vector containing the sums of the number of times each piece of data in the data pool has been processed by each model at time t minus 1. Right? And then d of t is the size of the data pool at a time t, and we can compute it by adding the initial size and then the monthly addition times the amount of months that have passed. Average process value over time, where the average process value for the entire data pool at a time t is graphed with for each AI model where they're separated by color. And so we see in the first 10 years, the growth of the average process value is approximately linear, but afterwards it begins to taper off in a logarithmic fashion. Recall the assumption that training an AI model on its own output is worse than training an AI model on different AI models as outputs. And so we can use assumption to conclude that the quality of ChatGPT will degrade faster than the quality of other models because it has larger average process values across all t. And we can see this in this graph. And note that the quality of an AI model's output is inversely proportional to its average process value.
To answer our original question about how the model output quality will be impacted over time by recursively training AI models on AI-generated output, since we already established that average processed value is inversely proportional to quality, we can see that in the first 10 years since November 2022, AI model output quality will decrease linearly since average processed value increases linearly during that period. And then we can see that after November 2032, AI model output quality will decrease at a slower, almost logarithmic rate all the way to, t goes to infinity, since average processed value increases at a logarithmic rate along the same time.
And so the effects of having multiple AI models in this process is that if we are training these AI models on human-made content, then we're going to attain higher output quality. And if we're training them on data processed by other models, then we're going to get some lower output quality, but by far the lowest output quality will be attained by training AI models on their own output. And so we can conclude that the presence of multiple AI models reduces the share of data that is processed by itself and thus slows the degradation of output quality.
Final note is on assessing model accuracy. Our model predicts a great decrease in model output quality for the first 10 years and a slower decrease in AI output quality afterwards, but in reality we actually expect AI model output quality to stay largely the same or even increase over time because AI companies will be filtering their data more. Our model doesn't consider this since it considers that every single data piece in the data pool at a time t will be used in the training of the AI, but that's not really true. AI companies will filter to only train their AIs on high quality data. Additionally, we suspect that more sophisticated AI algorithms will be built as AI companies gain more resources to put into their product.